May 8, 1942. Malinta Tunnel, Corregidor Island, Philippines. Lieutenant Commander Takeshi Nakamura stood in the humid darkness of the captured American fortress, his boots crunching on spent brass casings that littered the concrete floor. The battle for the Philippines had ended hours earlier with the surrender of the remaining American and Filipino forces. Around him, Japanese naval infantry sorted through abandoned equipment, but Nakamura's attention fixed on something more valuable than territory won or ammunition captured. In his hands, he held an M1 Garand rifle, serial number 1427693, still warm from the fighting. The rifle felt heavier than the Type 99 Arisaka that had served him throughout the China campaigns. Its walnut stock bore scratches and oil stains from months of combat, but the metal surfaces gleamed with careful maintenance. Nakamura had encountered American troops armed with these rifles during the final assaults on Bataan and Corregidor. What he experienced in those firefights challenged everything Japanese military doctrine had taught him about infantry combat. This wasn't just another captured weapon. This was a technological revelation that would force Japanese military planners to confront an uncomfortable truth about the nature of modern warfare. The sound of American semi-automatic fire had been unlike anything Japanese infantry had previously encountered. Not the measured crack-pause crack of bolt-action rifles, but a continuous roar of individual shots fired as quickly as triggers could be pulled. Japanese soldiers attacking American positions reported facing what seemed like machine gun fire from individual riflemen. The volume of incoming rounds forced even veteran assault troops to take cover, disrupting the aggressive infantry tactics that had served Japan so effectively in China and Malaya. Nakamura pulled back the operating rod handle, watching the bolt slide back smoothly. Examined the gas system, the rotating bolt, the trigger mechanism. Everything about this rifle spoke to a fundamentally different philosophy of infantry combat than what Japanese weapons designers had embraced. The Type 99 Arisaka represented the culmination of bolt-action rifle development, accurate, reliable, well-suited to soldiers trained in careful marksmanship. The M1 Garand represented something else entirely, the industrialization of firepower itself. The genesis of Japan's confrontation with American semi-automatic firepower began weeks earlier, during the defense of Bataan. American and Filipino forces, though desperately short of supplies and reinforcements, had held defensive positions far longer than Japanese planners anticipated. Part of this unexpected resistance came from the firepower advantage provided by M1 Garand rifles. Japanese intelligence officers interviewing wounded soldiers returning from Bataan attacks heard consistent reports. American riflemen could fire continuously without pausing to work bolt actions. The volume of defensive fire exceeded what should have been possible from the observed number of defenders. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The M1 Garand had arrived in the Philippines between August and November 1941, when American forces reinforced the Philippine Department in anticipation of potential Japanese aggression. While the majority of American and Filipino troops still carried M1903 Springfield or M1917 Enfield bolt-action rifles, several thousand M1 Garands equipped elite units, including the Philippine Scouts. These Filipino soldiers, trained to American standards and armed with American weapons, would demonstrate the M1's capabilities during the desperate fighting on Bataan. Lieutenant Colonel Philip Fry, commanding the 3rd Battalion, 57th Regiment, Philippine Scouts, witnessed firsthand what modern semi-automatic rifles could accomplish in defensive combat. His battalion, armed primarily with M1 Garands, generated firepower that repeatedly stopped Japanese attacks. In February 1942, Fry reported to higher headquarters that the volume of fire his scouts could produce exceeded anything he had previously experienced with bolt-action rifles. The psychological impact on attacking Japanese infantry proved substantial. Soldiers trained to expect measured rifle fire from defenders instead faced continuous semi-automatic fire that forced them into cover and disrupted assault formations. The capture of the Philippines in May 1942 provided Japanese forces with numerous examples of American equipment. At warehouses in Manila, Fort Stotzenberg, and other military installations, Japanese troops discovered stockpiles of weapons and ammunition. Among the captured equipment were several thousand M1 Garand rifles, many still in their original shipping crates, never issued to troops. The Japanese 14th Army, responsible for the Philippines campaign, reported capturing 27,412 rifles total, though the majority were M1903 Springfields and M1917 Enfields. The exact number of captured M1 Garands remains uncertain, but estimates range from several hundred to a few thousand rifles. The Imperial Japanese Navy, which maintained separate weapons development programs from the Army, immediately recognized the potential intelligence value of captured M1 rifles. Naval infantry, the Rikusentai, had faced American Marines on Wake Island and witnessed the defensive firepower that semi-automatic rifles provided. When word reached the Navy's technical services that intact M1 Garands had been captured in the Philippines, orders went out to transport selected examples back to Japan for comprehensive evaluation. By July 1942, at least a dozen M1 Garand rifles arrived at Yokosuka Naval Arsenal on Tokyo Bay. The arsenal, established in 1868, served as Japan's premier naval ordnance facility. Its technical staff included some of the nation's most experienced weapons designers and engineers. The captured American rifles represented an opportunity to examine firsthand the manufacturing methods and design principles that enabled mass production of semi-automatic infantry weapons. Commander Yoshio Ozawa headed the evaluation team at Yokosuka. An experienced ordnance officer with degrees in mechanical engineering from the Imperial Japanese Naval Academy, Ozawa had studied weapons design in both Japan and briefly in Germany during the early 1930s. He assembled a team of specialists, metallurgists to analyze steel quality and heat treatment, machinists to examine manufacturing techniques, and combat veterans to evaluate practical utility. The team's assignment was clear: document every aspect of the M1 Garand's design, determine how American industry produced such weapons in quantity, and assess whether Japanese factories could manufacture similar rifles. The examination began with complete disassembly. Every component was measured, weighed, and documented. The walnut stock, trigger mechanism, gas system, barrel, bolt assembly. Each element received detailed scrutiny. What the Japanese engineers discovered challenged their understanding of both weapons design and industrial production methods. The M1 Garand embodied engineering principles fundamentally different from Japanese military rifles. The Arisaka rifles that equipped Japanese infantry represented traditional weapons manufacturing philosophy. Skilled craftsmen fitted components individually to each rifle. No two Arisakas were truly identical. Replacement parts required adjustment by trained armourers before installation. This approach produced excellent rifles, but it limited production rates and made field maintenance complex. The M1 Garand appeared to follow opposite principles. Components seemed designed for complete interchangeability without individual fitting. Engineers at Yokosuka disassembled multiple captured M1 rifles, comparing components across different serial numbers. Gas cylinders from one rifle fit perfectly on another. Trigger assemblies could be swapped between rifles with no adjustment needed. Operating rods, bolts, hammers, every major component appeared interchangeable. This level of standardization required manufacturing precision that Japanese ordnance factories had not achieved. American industry evidently possessed machine tools, capable of producing components to tolerances measured in thousandths of an inch, with consistency across thousands of rifles. The M1's gas system demonstrated elegant engineering. When a cartridge fired, propellant gases pushed the bullet down the barrel. A small port drilled in the barrel diverted some gas into a cylinder below. This gas drove a piston attached to the operating rod. The rod's rearward movement unlocked the bolt, extracted the spent cartridge case, cocked the hammer, and compressed a spring. When the operating rod reached its rearmost position, spring pressure drove it forward. chambering a fresh cartridge from the clip and locking the bolt. The entire cycle took a fraction of a second and occurred automatically with each trigger pull. Japanese engineers had experimented with gas-operated systems in prototype rifles during the 1930s, but none achieved the reliability demonstrated by the M1 Garand. The American rifle's gas system functioned consistently despite dust, dirt, and minimal maintenance. Combat reports from the Philippines confirmed this reliability. American soldiers reported M1 rifles functioning for days without cleaning, operating normally despite exposure to tropical humidity and volcanic dust on Corregidor. The bolt mechanism revealed sophisticated engineering. The rotating bolt locked into the receiver, with 8 locking lugs, providing secure lockup capable of handling the high pressures generated by .30-06 Springfield ammunition. The bolt's rotation occurred automatically as the operating rod cycled. No manual manipulation was required. The soldier simply pulled the trigger for each shot. In contrast, Japanese bolt-action rifles required the soldier to manually unlock the bolt, pull it rearward to extract the spent case, push it forward to chamber a new round, and rotate it down to lock before firing again. This manual operation necessarily interrupted the shooter's sight picture and slowed rate of fire. The trigger mechanism demonstrated careful design for combat use. The trigger pull measured approximately 5 to 6 pounds, heavy enough to prevent accidental discharge, but light enough for accurate shot placement. The safety, a rotating lever in the trigger guard, could be operated quickly even with cold or gloved hands. Every aspect of the rifle's controls seemed designed for soldiers under stress, in darkness, in harsh conditions. The M1's feeding system used an 8-round N-block clip, a metal clip that contained the cartridges and was inserted as a unit into the rifle's action. When the last round fired, the clip automatically ejected with a distinctive metallic ping. Japanese engineers noted this sound might alert enemies to an empty rifle, though combat veterans among the evaluation team doubted the ping would be audible in the noise of battle. The clip system allowed rapid reloading. A trained soldier could reload in 2 to 3 seconds, simply by pushing a fresh loaded clip into the rifle's receiver. In September 1942, Yokosuka arranged field testing of the captured M1 rifles. Naval infantry from the 3rd Special Naval Landing Force participated in the evaluation, firing the American rifles on the arsenal's test ranges. The soldiers, all combat veterans with extensive experience using Arisaka rifles, reported their impressions. The M1 Garand was heavier than the Type 99, at approximately 9.5 pounds compared to the Arisaka's 8.2 pounds. However, the American rifle's semi-automatic operation more than compensated for the extra weight. A soldier armed with an M1 could fire 30 to 40 aimed shots per minute, compared to perhaps 15 aimed shots per minute with a bolt-action Arisaka. The practical implications became clear during timed fire exercises. Teams of soldiers armed with M1 Garands could engage targets at rates that approached light machine gun fire, while maintaining the accuracy of rifles. Japanese observers noted that an American infantry squad, armed with M1 rifles, could generate firepower equivalent to a Japanese squad with its mix of bolt-action rifles and a Type 96 light machine gun. More significantly, the American firepower was distributed across every rifleman rather than concentrated in one crew-served weapon. The metallurgical analysis revealed additional insights about American manufacturing capabilities. The M1's receiver, the main body of the rifle, was forged from high-quality steel and machined to precise dimensions. The barrel steel demonstrated excellent heat treatment, with proper hardening that would ensure long service life. The operating rod appeared to be a carefully engineered component, forged rather than machined from bar stock, then heat-treated to specific hardness levels. Every metal component examined showed evidence of systematic quality control and precision manufacturing. Japanese steel production in 1942 faced significant challenges. The nation imported much of its iron ore and relied on coke produced from imported coal. Steel mills operated at capacity, but could not match American production volumes. More critically, Japanese steel varied in quality depending on the source of raw materials, and the specific plant producing it. American steel, in contrast, appear remarkably consistent across different components and different rifles. This consistency suggested systematic quality control throughout the production process, from raw material selection through final machining. By late 1942, Commander Ozawa's team had compiled extensive documentation on the M1 Garand. Technical drawings illustrated every component. Specifications listed dimensions, tolerances, materials, and heat treatment procedures. Test reports documented performance under various conditions. The evaluation concluded that the M1 represented a highly effective infantry rifle, vastly superior to bolt-action weapons in rate of fire while maintaining adequate accuracy and reliability. More troubling, the evaluation concluded that Japanese ordnance factories could not manufacture M1 Garands using existing equipment and production methods. The problem wasn't understanding the design. Japanese engineers comprehended how the gas system worked, how the rotating bolt locked, how the feeding mechanism operated. The problem was manufacturing. The M1 required precision machining operations that Japanese factories were not equipped to perform at scale. The receiver alone required dozens of machining operations using milling machines, drilling machines, and grinding machines capable of holding tolerances measured in thousandths of an inch. Japanese ordnance factories possessed such machines, but not in quantities sufficient for mass production of complex semi-automatic rifles. American industry evidently organized production differently than Japanese factories. Rather than skilled craftsmen individually fitting parts, American factories used precision machinery to produce interchangeable components. This approach required massive capital investment in machine tools, dies, and fixtures. Once that investment was made, however, production could scale rapidly by adding more machines and training relatively unskilled workers to operate them. Japanese industry, facing capital shortages and prioritizing ship and aircraft production, had not made equivalent investments in small arms manufacturing technology. The captured M1 Garands also revealed clues about American production capacity. Serial numbers on the rifles examined at Yokosuka ranged from the low 100,000s to the mid-200,000s. Springfield Armory, the primary M1 manufacturer, began production in 1937. By mid-1942, the armory had produced several 100,000 rifles. Japanese analysts calculated approximate production rates based on serial number sequences and dates stamped on components. The numbers proved sobering. Springfield Armory alone appeared capable of producing M1 rifles at rates exceeding Japan's total rifle production across all manufacturers. In November 1942, as American forces landed in North Africa and Japanese forces struggled to maintain positions on Guadalcanal, Commander Ozawa submitted his final report to Navy headquarters. The report praised the M1 Garand's design and acknowledged its superiority over bolt-action rifles. More significantly, the report concluded that Japan faced a critical firepower disadvantage in infantry combat against American forces. Japanese soldiers armed with Arisaka rifles could not match the rate of fire that M1-equipped American soldiers achieved. In squad-level engagements, this firepower disparity would prove decisive. The report recommended that Japan develop its own semi-automatic infantry rifle as a high priority. However, Ozawa noted substantial obstacles to rapid development. Japanese industry lacked the machine tools necessary for mass production of complex semi-automatic rifles. Existing production capacity was fully committed to manufacturing Arisaka rifles, light machine guns, and other critical weapons. Introducing a new rifle design would require diverting resources from current production, likely causing temporary decreases in total output. Most critically, the time required to design, test, tool up for production, and train workers would measure in years, not months. The reality of Japan's strategic situation in late 1942 made Ozawa's recommendations difficult to implement. The nation was fighting across a vast Pacific perimeter, from the Aleutians to New Guinea, from Burma to the Gilbert Islands. Every day required thousands of rifles for newly trained troops, replacements for combat losses, and equipment for garrison forces. Japanese ordnance factories operated at maximum capacity, producing Arisaka rifles using existing tooling and trained workers. Any disruption to this production would immediately affect the military's ability to equip infantry forces. The Imperial Japanese Army, which controlled the majority of ordnance production, showed limited interest in semi-automatic rifles. Army leadership emphasized marksmanship training and aggressive infantry tactics. Army doctrine stressed the importance of each carefully aimed shot rather than volume of fire. Army weapons designers had experimented with semi-automatic rifles during the 1930s, but none of the prototypes met Army requirements for reliability, simplicity, and cost. With war spreading across Asia and the Pacific, Army ordnance continued focusing on proven designs that could be manufactured in quantity with existing resources. The Imperial Japanese Navy maintained separate weapons development programs and held different views on infantry weapons. Naval infantry operated independently from army forces and often faced different tactical situations. Landing operations and island defense required weapons suited to close-range combat, where rate of fire mattered more than long-range accuracy. The Navy's experience fighting American Marines, who began receiving M1 Garands in significant numbers during 1943, convinced Navy planners that semi-automatic rifles deserved serious consideration. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. In early 1943, as American forces began their offensive across the Pacific, Japanese naval infantry on Guadalcanal and New Georgia reported increasingly heavy firepower from American positions. Marines advancing through jungle terrain fired continuously without pausing to work bolt actions. The sustained fire forced Japanese infantry to remain in cover, preventing the close-range assault tactics that had proved effective against Chinese and British forces. After-action reports consistently noted that American Marine units armed with M1 rifles could generate defensive fire volumes that exceeded expectations based on observed troop numbers. The Battle of Tarawa in November 1943 provided Japanese defenders with extensive experience against M1-equipped Marines. The 4th and 5th Special, Naval Landing Forces, occupying heavily fortified positions on Batio Island, held defensive advantages that should have made the atoll nearly impregnable. When Marines came ashore, they faced interlocking fields of fire from concrete emplacements, log bunkers, and coral trenches. The fighting lasted 3 days of brutal close-range combat. Despite horrendous casualties crossing the reef and beach, Marines eventually overran Japanese positions through continuous fire and movement tactics enabled by M1 Garands. Japanese survivors from Tarawa, evacuated to Truk before the island fell, reported that Marine rifle fire was overwhelming. Every Marine seemed to carry a semi-automatic rifle, firing as quickly as triggers could be pulled. Traditional defensive tactics, allowing attackers to close while holding fire until optimal range, failed because Marines suppressed defensive positions with continuous rifle fire while other Marines maneuvered. The volume of incoming rounds made it difficult for defenders to maintain aimed fire, even from fortified positions. By early 1944, the strategic situation had deteriorated severely. American forces were pushing through the Marshall Islands, approaching the Marianas, threatening Japan's inner defensive perimeter. The Imperial Japanese Navy faced the reality that naval infantry would soon defend islands close to the home islands themselves. Equipment shortages already affected operations. Ammunition supplies ran short. Replacement weapons became difficult to obtain. Against this background, Navy planners returned to the question of semi-automatic rifles. In March 1944, the Imperial Japanese Navy formally initiated a program to develop a semi-automatic rifle for naval infantry. The program operated under severe constraints. Resources for weapons development were scarce. Steel allocations prioritized ship construction, aircraft production, and army requirements. Machine tools were in short supply. Skilled engineers and technicians were spread thin across multiple urgent projects. The Navy needed a semi-automatic rifle, but developing an entirely new design from scratch would require years Japan did not have. Commander Ozawa, who had led the 1942 evaluation of captured M1 Garands, proposed a pragmatic solution. Rather than designing a new rifle, copy the M1 Garand, the American rifle's design was proven in combat. Its operating principles were well understood from the captured examples at Yokosuka. By reverse engineering the M1, Japan could skip the lengthy development and testing phases that had plagued previous semi-automatic rifle programs. The copy could be chambered for the 7.7mm Arisaka cartridge, which was dimensionally similar to 3006 Springfield, simplifying ammunition logistics. The proposal faced skepticism from some Navy officers who considered copying enemy equipment beneath Japanese dignity. National pride and military culture emphasized original Japanese designs, not imitations of foreign weapons. However, pragmatists noted that Japan had successfully adapted foreign technology in the past. The Arisaka rifle itself incorporated features from Mauser designs. The Type 96 light machine gun drew heavily on the Czechoslovakian ZBVZ-26. Adapting proven foreign technology had served Japan well before. In wartime, results mattered more than pride. In April 1944, Yokosuka Naval Arsenal began work on a Japanese version of the M1 Garand. The project moved forward with urgency, though it remained a low priority compared to ship repairs, torpedo production, and aircraft maintenance. The captured M1 rifles served as patterns. Engineers created detailed technical drawings, measuring every dimension of every component. The challenge lay not in understanding what needed to be built, but in actually building it with available resources and equipment. Initial work focused on adapting the design to Japanese manufacturing capabilities and ammunition. The 7.7mm Type 99 cartridge used by Japanese forces had similar dimensions to 3006 Springfield, but subtle differences in case taper and shoulder angle meant the M1's chamber required modification. More significantly, Japanese engineers decided to eliminate the M1's 8-round N-block clip system. The clip system required precision-manufactured clips that would be difficult to produce in quantity. Instead, the Japanese design used a fixed 10-round internal magazine fed by two 5-round stripper clips, the same stripper clips used to load Arisaka rifles. This modification required substantial redesign of the rifle's receiver and feeding mechanism. The M1's receiver was designed around the N-block clip system, with the clip itself serving as part of the magazine assembly. A fixed magazine required a different receiver design, with a hinged floor plate and a follower system to push cartridges upward. Engineers at Yokosuka redesigned the lower receiver to accommodate a 10-round box magazine while maintaining the M1's gas system and rotating bolt. The modifications added complexity to an already complex design. By mid-1944, Yokosuka completed design drawings for the Japanese Garand copy. The rifle retained the M1's gas-operated, rotating bolt action. The gas port location, gas cylinder diameter, and operating rod design closely followed the American rifle. The trigger mechanism was simplified slightly but functioned similarly. The most visible changes were the fixed magazine, stripper clip guides machined into the receiver, and Japanese-style tangent rear sight replacing the M1's aperture sight. The stock used traditional Japanese two-piece construction, with sections of wood glued together, rather than the single-piece walnut stock of the M1. Manufacturing the prototype rifles presented enormous challenges. Yokosuka Naval Arsenal possessed skilled workers and precision machine tools, but capacity was limited. Every machinist, every lathe, every milling machine was already committed to urgent Navy work. The semi-automatic rifle project proceeded in stolen moments between priority tasks. Engineers worked evenings and weekends, treating the project almost as a private initiative rather than an official program. Parts were fabricated one at a time in the Arsenal's experimental shop, using methods that would never scale to mass production. The first prototype Japanese Garand was completed in July 1944. The rifle resembled an M1 Garand, but with distinctly Japanese features. Test firing revealed immediate problems. The modified feeding system jammed frequently. Cartridges failed to feed smoothly from the fixed magazine. The follower spring tension was insufficient to reliably push cartridges upward. The stripper clip guides, machined into the receiver's top surface, interfered with bolt travel during certain malfunctions. Engineers adjusted designs, modified parts, tested again, found new problems. Through late 1944 and into 1945, Yokosuka continued refining the design. Each prototype revealed flaws that required correction. The rifle's reliability slowly improved as engineers solved feeding problems, adjusted gas port sizes, and refined component dimensions. By early 1945, the design had stabilized sufficiently that Yokosuka began limited production of what was designated the Type 4 rifle, named for the Japanese imperial year 2604, corresponding to 1944 in the Western calendar. Production remained painfully slow. Each receiver required dozens of machining operations. The barrel, forged and drilled at a separate facility, then delivered to Yokosuka for final machining and fitting. Operating rods, bolts, trigger assemblies, all were manufactured individually by skilled machinists using methods suitable for prototype fabrication, but wholly inadequate for mass production. The arsenal managed to produce approximately 250 sets of parts by April 1945. Of these, perhaps 100 complete rifles were assembled before work stopped. The Type 4 rifle never reached combat. The weapons remained at Yokosuka Naval Arsenal, used for testing and training but never issued to naval infantry. By the time production began, American forces had captured Iwo Jima and Okinawa. B-29 bombers struck Japanese cities nightly. The Navy faced shortages of fuel, ammunition, and basic supplies. Semi-automatic rifles, regardless of their firepower advantages, could not address the strategic collapse Japan faced in early 1945. The lessons learned from examining captured M1 Garands extended far beyond the immediate question of semi-automatic rifle production. Japanese engineers recognized that the M1 represented a fundamentally different approach to weapons manufacturing, one that prioritized interchangeable parts, precision tooling, and systematic production over skilled craftsmanship and individual fitting. This approach enabled American industry to produce complex weapons at scales Japanese factories could not match. When American forces occupied Japan in August 1945, they discovered the Type 4 rifles at Yokosuka Naval Arsenal. Approximately 125 complete rifles were found, along with parts for another 125 that had never been assembled. Allied ordnance officers examined the rifles with professional interest. The quality of workmanship impressed them. Despite severe material shortages and bombing damage to Japanese industry, the Type 4 rifles showed careful machining and assembly. They were clearly products of skilled workers using whatever resources remained available. American ordnance officers also visited Washino Kikai Company in Aichi Prefecture, where additional Type 4 production had been planned. The factory had received orders to manufacture Type 4 rifles in quantity, but production never truly began. Washino possessed no specialized machinery for rifle production. The company had been assembling rifles from parts fabricated at Yokosuka, but only 50 rifles had reached partial completion when production stopped. The factory workers, facing constant air raids and material shortages, never received final specifications or assembly instructions that would have enabled volume production. Testing of the captured Type 4 rifles revealed the problems that had plagued the program. The rifles functioned, but reliability issues persisted. The 7.7mm Arisaka cartridge generated slightly less pressure than .30-06 Springfield. This reduced pressure sometimes proved insufficient to cycle the action reliably. The gas port size required careful calibration. Too small, and the rifle wouldn't cycle, but consistently. Too large and excessive gas pressure caused premature wear on components. Japanese engineers had struggled to find the optimal gas port diameter, but limited testing time and ammunition shortages prevented thorough development. The fixed magazine feeding system, while theoretically sound, showed feeding problems under field conditions. cartridges occasionally jammed during feeding from the magazine. The follower spring tension needed precise adjustment. The stripper clip guides sometimes interfered with smooth feeding. These were solvable problems, the kind of issues that normally get resolved during extensive testing and development. But Japan, in 1945, lacked the time, resources, and ammunition to conduct the testing necessary to perfect the design. 20 Type 4 rifles were selected by American ordnance officers for detailed study and preservation. These rifles were shipped to the United States, where they eventually found their way into military museums and private collections. The remaining Type 4 rifles and parts remained at Yokosuka, where they were eventually scrapped or lost to history. Today, Type 4 rifles rank among the rarest and most sought-after Japanese military weapons, with surviving examples valued at tens of thousands of dollars by collectors. The story of Japanese engineers examining captured M1 Garands and attempting to copy them revealed broader truths about industrial warfare in the 20th century. The M1 Garand succeeded not just because of John Garand's brilliant design, but because American industry possessed the manufacturing infrastructure to produce complex weapons at scale. Machine tools, precision measurement equipment, quality control systems, skilled tool and die makers, engineering expertise, all these elements combined to enable mass production of semi-automatic rifles. Japan, despite possessing skilled engineers and craftsmen, lacked the industrial infrastructure necessary to match American production. Japanese factories could build excellent weapons using traditional manufacturing methods, but these methods could not scale to meet wartime demand for increasingly complex weapons. The gap between Japanese and American industrial capacity widened throughout the war as American factories expanded, while Japanese factories faced bombing, resource shortages, and infrastructure damage. The firepower disparity that Japanese infantry faced in combat against M1-equipped American forces proved decisive in countless small unit engagements. Japanese soldiers, regardless of their training, courage, or tactical skill, could not overcome the mathematical reality that American soldiers could fire 2 to 3 times as many aimed shots in the same period. In squad-level firefights, this advantage compounded, allowing American infantry to suppress Japanese positions and maneuver effectively even when outnumbered. Japanese military leadership recognized this firepower disadvantage. After-action reports from every theater consistently noted the overwhelming volume of American rifle fire. Commanders adjusted tactics, emphasizing night attacks when American firepower advantages were reduced, defensive positions that maximized cover and concealment, and close-range assault tactics that negated the M1's rapid-fire capability. These tactical adjustments helped, but could not eliminate the fundamental advantage that semi-automatic rifles provided. The broader strategic implications of the firepower disparity became apparent as the war progressed. American infantry, armed with M1 Garands and supported by overwhelming artillery, air power, and logistics, advanced steadily across the Pacific despite fierce Japanese resistance. Each island battle demonstrated that Japanese defensive tactics, while inflicting heavy casualties, could not ultimately prevent American victory. The combination of American firepower, industrial capacity, and manpower proved insurmountable. In the decades after World War II, Japan's relationship with the M1 Garand took an ironic turn. As Japan rebuilt under American occupation and established the Japan Self-Defense Forces, the new Japanese military needed weapons. The United States provided military aid to its former enemy, now a Cold War ally against communist expansion in Asia. Among the weapons provided were tens of thousands of M1 Garand rifles, the same weapon Japan had tried unsuccessfully to copy during the war. Japanese self-defense force troops trained with M1 Garands throughout the 1950s and into the early 1960s. The rifles that Japanese engineers had examined with such professional interest at Yokosuka Naval Arsenal now equipped Japanese infantry, this time as gifts rather than prizes of war. Japanese soldiers learned to maintain, shoot, and field strip M1 Garands according to American military manuals. The irony was not lost on veterans who had faced American firepower during the war. The M1 Garand served the Japan Self-Defense Forces until the early 1960s, when Japanese industry finally developed and produced an indigenous semi-automatic rifle, the Type 64. This rifle, chambered for a reduced-power 7.62mm cartridge, incorporated lessons learned from examining captured American weapons decades earlier. The Type 64 used a gas-operated, tilting bolt-action and detachable 20-round magazine. While not a copy of the M1, the Type 64's development benefited from Japanese engineers' understanding of gas-operated semi-automatic rifle systems gained through studying captured American weapons. The manufacturing methods that Japanese engineers observed in captured M1 Garands influenced Japan's post-war industrial development. Japanese industry, rebuilding from wartime devastation, adopted systematic production methods similar to those American industry used. Precision machinery, interchangeable, parts, quality control systems, automated production lines, all became standard in Japanese factories during the 1950s and 1960s. The emphasis shifted from skilled craftsmen individually fabricating products to systematic processes that ensured consistent quality across high-volume production. This industrial transformation occurred across all manufacturing sectors, not just weapons production. Japanese automobile manufacturers, electronics companies, and machinery producers implemented production systems that emphasized precision, consistency, and continuous improvement. By the 1970s, Japanese manufacturers competed successfully against American companies using techniques partially inspired by studying American manufacturing methods, including those observed in captured American military equipment. The Type 4 rifle project represented Japan's final attempt during World War II to address the infantry firepower disparity through technology. The program failed not because Japanese engineers lacked understanding of semi-automatic rifle design, but because Japanese industry lacked the capacity to manufacture such weapons in militarily significant numbers, while simultaneously producing ships, aircraft, artillery, and all the other materiel required for total war. The program's failure highlighted the fundamental mismatch between Japan's industrial capabilities and its strategic ambitions. Commander Yoshio Ozawa, who led the original evaluation of captured M1 Garands in 1942, survived the war and continued working in weapons development for the Japan Self-Defense Forces during the 1950s. He witnessed Japanese soldiers training with American-supplied M1 Garands and participated in development of indigenous Japanese weapons that incorporated lessons learned from studying American designs. His career spanned the transformation of Japanese military technology, from craftsman-based production to modern, industrial manufacturing. The handful of Japanese naval infantry who might have received Type 4 rifles before the war ended never got the chance to use them in combat. The rifles remained at Yokosuka, carefully maintained but never issued, as Japan faced strategic collapse in the summer of 1945. Naval infantry units that might have benefited from semi-automatic rifles were instead destroyed in futile defensive battles on Iwo Jima, Okinawa, and countless other islands, armed with Arisaka bolt-action rifles as they faced American Marines equipped with M1 Garands. The examination of captured M1 Garands taught Japanese engineers valuable lessons about American industrial methods and the nature of modern warfare. These lessons, purchased at the cost of military defeat, informed Japan's post-war industrial development. The nation that had struggled unsuccessfully to mass-produce semi-automatic rifles during wartime became, within 2 decades, an industrial powerhouse, capable of manufacturing complex products to exacting standards at competitive prices. The M1 Garand's influence on Japanese thinking extended beyond technical specifications and manufacturing methods. The rifle represented a philosophy of warfare that prioritized providing soldiers with superior equipment, even if that equipment cost more and required more sophisticated production methods. American military leadership invested heavily in soldier capabilities, recognizing that individual soldier effectiveness multiplied across millions of troops produced enormous advantages. This investment in people and equipment contrasted with Japanese military philosophy, which emphasized fighting spirit and self-sacrifice over technological superiority. The few surviving Type 4 rifles serve as physical reminders of an ultimately futile attempt to close an unbridgeable gap. Japan in 1944 and 1945 lacked the time, resources, and industrial capacity to develop and produce semi-automatic rifles in numbers that would have materially affected the war's outcome. Even if the Type 4 had been perfected and put into mass production, American industrial advantages in every other category would have ensured eventual Allied victory. The rifle represented Japan's recognition of American technological superiority, but recognition alone could not overcome the reality of American industrial might. The story of Japanese officers studying captured M1 Garands illuminates the human dimension of industrial warfare. Engineers and soldiers, doing their best with limited resources, recognized the superiority of enemy equipment and attempted to replicate it. Their efforts, though ultimately unsuccessful, demonstrated professional dedication and technical competence. They understood what needed to be done, but lacked the means to accomplish it. This gap between understanding and capability defines much of Japan's World War II experience. Today, collectors and historians value surviving Type 4 rifles as tangible connections to a moment when Japan attempted to adopt American weapons technology. Each rifle represents months of engineering work, careful fabrication by skilled machinists, and the broader story of Japan's struggle to compete industrially with the United States. The rifle's rarity makes them sought-after collectibles, but their historical significance extends far beyond monetary value. They represent a road not taken, a weapon that might have altered tactical engagements, but could never have changed strategic outcomes. The M1 Garand's legacy includes its influence on former enemies, who recognized its effectiveness. German weapons designers developed the Gewehr 43 semi-automatic rifle, partially in response to facing American and Soviet semi-automatic rifles. Japanese engineers attempted to copy the M1 directly. Soviet designers incorporated lessons learned from their SVT-40 semi-automatic rifle into post-war weapons development. The M1 Garand's combat success drove global recognition that semi-automatic rifles represented the future of infantry weapons. The Type 4 rifle project concluded as it began, with Japanese recognition of American technological and industrial superiority. The captured M1 Garands that Japanese engineers examined so carefully at Yokosuka Naval Arsenal demonstrated capabilities that Japanese industry could admire, but not replicate. The rifle's precision manufacturing, interchangeable parts, and reliable function under harsh conditions all pointed to systematic production methods that required industrial infrastructure Japan lacked. Understanding this reality didn't diminish Japanese engineers' professional competence, but it did highlight the vast differences in industrial capacity between the two nations. The firepower advantage that M1 Garands provided American infantry formed just one element of overall American military superiority, but it was the element most immediately apparent to Japanese soldiers in combat. Superior artillery, air power, naval forces, and logistics all contributed to American victory, but these operated at levels above the individual soldier's direct experience. The rifle was personal, immediate, tangible. Japanese infantry could see, hear, and experience American firepower advantage with every engagement. They knew their opponents carried better rifles, and this knowledge affected morale as surely as actual casualties affected combat strength. The examination of captured M1 Garands by Japanese officers represents a specific moment in a larger story about technology, industrial capacity, and the nature of modern warfare. Individual weapons rarely determine war's outcomes, but the M1 Garand contributed materially to Allied victory by providing American infantry with a decisive firepower advantage at the squad level. Japanese recognition of this advantage, demonstrated through their effort to copy the M1, validated American investment in soldier equipment and vindicated John Garand's decades of design work. The rifles that Japanese engineers examined at Yokosuka, serial numbers carefully recorded, dimensions precisely measured, functions thoroughly tested, taught their examiners that American industrial power extended beyond raw production numbers to systematic manufacturing excellence. This lesson, learned too late to affect the war's outcome, influenced Japan's post-war industrial development and contributed to the nation's emergence as a global manufacturing leader in subsequent decades. The M1 Garand thus played an unexpected role in shaping post-war Japanese industry, not through direct technology transfer, but through demonstrating the possibilities of systematic, precision manufacturing at scale. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.